G'day and welcome to the next video on this linear function series. We are looking at now the midpoint and the distance between 2 points. So if we want to connect any 2 points with a straight line, we actually call this an interval. All right, so remember that we've got a line that goes on, it goes on forever in a certain direction, but if we're going to stop it at 2 points, such as this example down here, you'll see that's actually what we call an interval. Now the midpoint is actually found by averaging out the 2 x coordinates and the 2 y coordinates. We're essentially finding where is the point that is halfway between those. And we can think about it in terms of the horizontal, so x coordinates, and the vertical in terms of our y coordinates. So to do that, as I said, we've averaged out, we're taking the mean of those separate coordinates. This is a nice little formula that we have here, noting that we've got big or a capital M to represent midpoint in this circumstance. Not to be mixed up with gradient, where we use that little m. So you can see if I've got my coordinates being x1, y1 and x2, y2, we simply average out or go x1 plus x2 divided by 2 for those x coordinates, and the same for our y coordinates. If I want to look at that graphically, you can see I've got my 2 points here, a point at 1, 3 and a point at 3, minus 1. I've just labeled them to be x1, y1 and x2, y2. It doesn't matter which point you choose to be that, but we need to make sure that we make our x1 align with our y1. All right, so we wouldn't make that x1, y2. We make sure it's x1, y1 and vice versa. It doesn't actually matter too much with my midpoint formula, but when I go on to distance in my next one, it is really important that we get those right. So our midpoint, as you can see graphically, it's obviously going to lie on that interval halfway between. We can do that algebraically. You see we've just gone the x1 plus x1 plus x2, which is 1 plus 3 divided by 2. And then for the y coordinate, we're adding together those. So 3 plus minus 1 here gives us 3 minus 1 over 2. And we end up with our midpoint, which is 2, 1. Let's have a look at a couple of examples. So let's find the midpoint between the points 2, minus 2 and minus 6, 7. So I'm going to straight away just go straight for my formula. So I've remembered and I've learnt. So I know that m equals, and I'm just going to go and straight use these. Remember that there's going to be x1, x2. So I'll go 2 minus 6 divided by 2, comma, minus 2 plus 7 over 2. So we've averaged out our x coordinates and then our y coordinates. And so remember our answer is going to be a coordinate. So 2 minus 6 is minus 4 divided by 2 is minus 2, comma, minus 2 plus 7 is going to give me 5 divided by 2. I'm just going to leave it as an improper fraction here, 5 over 2 for ease, but you could write it as 2.5 as well. Let's have a look at the second one. The midpoint between points A and B is 4 minus 2. If point A has the coordinates 1, 3, find the coordinates of point B. Okay, so this is a different style of question. Essentially, we are given the midpoint, and this time what we want to do is we actually want to find what is the other point. So our midpoint is this point here, 4 minus 2. If we want to use now we've got our point A being 1, 3. Now we're going to use a technique here which is actually going to be even easier than using the formula. And I really encourage my students to learn this, particularly as you go on to dividing intervals externally and internally once you get onto later years in extension maths. So what I'm going to do is I'm going to actually write up my points. So I've got point A here at 1, 3. And then I've got my midpoint, which is somewhere in between, and that's at 4 minus 2, and then I've got point B. Okay, so just thinking about what's going on, my midpoint is halfway between these. Doesn't matter if it's above or below, but it's halfway between. And what I actually want to do is I want to track what's going on. So if I've gone from 1 down to 4 here, what's happened? You can see that I've actually gone plus 3. And so to make sense, if that's halfway, I've added 3, I'm going to add another 3 to go down to my B. So I just go 4 plus 3 equals 7. And using the same idea with my y coordinates, I'm going to go here 3. What's happened to my 3 to make it a minus 2? Well, I've gone down 5. So I've minus 5 to go from 3 to minus 2. And so what do I need to do to keep going? If that's halfway, I need to minus another 5 down here. So minus 2 minus another 5 is minus 7. And it's as simple as that. We don't actually need to use the formula, even though you could substitute it in and go and solve it. This is actually a really fantastic technique. And as I said, if you understand this now, it's going to help you if you go to that stuff later in kind of year 11 and year 12 where we divide intervals in terms of internal or external ratios, so not in what we call one-to-one. I'm not going to stress on that now because it might confuse or scare you. Let's keep going on to distance between 2 points. So to find the distance between 2 points, basically we're going to use Pythagoras' theorem. We're going to create a right-angled triangle and then apply Pythag. So if you think about that graphically, I've got a point here, 4, 2, and I've got another point, 6, 5. And I say, well, how far are they apart? What's the distance between them? We can create ourselves a nice little right-angled triangle here, considering, well, how far have we moved across horizontally, i.e. what's been my change in x-coordinate, and how far have I moved vertically, what's been my change in y-coordinate. And so you can see I've done it here. I've gone, well, x has gone from 4 to 6, so it's gone up 2. Now run is 2. And we've gone from y equals 2 to y equals 5. It's gone up 3. From there, I'm sure you guys, if I just gave you a triangle like that and said, what's the hypotenuse, you would punch that straight into Pythag and you would happily end up with the following sort of situation. You're going to go that this, well, I'm going to call that d, so we'll say d squared equals 2 squared plus 3 squared. So d squared equals 4 plus 9. D squared equals 13. And so d equals square root of 13 units. Now, obviously we don't bother with the plus minus. We know it's a length, so we can't be negative. The other thing is I'm going to leave it as a surd of root 13 because that's exact. If you wanted to go and they asked you in a question to put it to a decimal place, I could say, well, that's approximately equal to 3.6 units. If I wanted to do it to one decimal place, that would work as well. Now we can actually find a formula for this, and it can make things easier if you didn't want to graph it out, but it is working on that exact principle of Pythagoras' theorem. And basically what it's saying is, well, let's work out what the change is horizontally. So this is our change horizontally. We just simply go x2 minus x1. You look at that example up there. We've gone 6 minus 4 to get that distance of 2. So that's what they're doing. That's our horizontal change in distance here. And then if I wanted to do my vertical change in distance, I'm going to go y2 minus 1. Now once again, it doesn't actually matter which coordinate you choose as x1, y1 and x2, y2, but we just got to be consistent to make sure that we're finding those. Now with Pythagoras, we know we square those values. So essentially this is ending up with what we had just up the top there. It'll become d squared equals a squared plus b squared. And obviously they've just taken the square root of both sides. So d equals the square root of a squared plus b squared in here, showing that our a and our b are those funky little expressions there using our x and y coordinates. So it is a useful formula for you, and we can just plug and play that. One little note I will say is remember that distance should always have units. So a distance is a length, and so we actually use the units for the Cartesian plane is actually the word units. And so we put that after it in our final answer. Don't forget to do that, and you'll see that I've done that up there in those questions. I've said 3.6 units. That's what we want to have. Let's have a look at some examples. So let's find the distance between the following pairs of points. I've got minus 4, 3, and 0, 0. So this one's a pretty straightforward one. We can just draw a nice little triangle here and try and hit the mark. We can just apply Pythag. How far is it going across? Hopefully you can see my base length there. It's gone across 4, it's gone up 3. And so by Pythag, I can clearly just go, well, d equals the square root of 3 squared plus 4 squared. Don't stress that I've switched the order there. That's going to give me square root of, if I simplify that, 25, which is 5 units. All right, that was nice and straightforward. Let's have a look at B. And this one, I'm given the coordinates, so I'm going to have a crack at trying to use my formula. And if you want, you can actually just write in what those things are. So remember, this is x1, y1, and this is x2, y2. And a lot of students just find it easier to write those in and then write our formula out first, and then we can just substitute into it. So our formula, remember, was d equals square root of x2 minus x1 squared plus y2 minus y1 squared. Guys, it is great to learn your formulas. Okay, if you know your formulas, it's going to make life easier for you. But at the same time, I'm thinking, what's going on with this formula? All it is, it's just a fancy application of Pythagoras' theorem. It shouldn't be too scary for you. So I'm just going to literally connect the dots, put in those blanks of what we know. So we're going to plug in our values, x2, so minus 4, minus 5, I'm just matching these up, squared, plus y2, minus 6, minus 2, all squared. Let's do this. So minus 4 minus 5 is minus 9 squared is 81, plus minus 6 minus 2 is minus 8 all squared is going to be plus 64. Noting we should always get a positive value here. Each of these should always be a positive value. Be careful when you put it in your calculator. If you press into your calculator minus 8 squared, it'll actually give you minus 64, which is not what we want. We know that a square number of a real number is always positive. So we're just going to make sure we don't stuff that up. So 81 plus 64, I just chucked that in a calculator that I refer to as old mate. And we're left with root 145. And remember, don't forget to put that units in there. If you wanted to put that, if they asked you, they said, oh, we want this to 2 decimal places or something like that, we could write that as well. So 12.04 units, showing that I've done that to 2 dp. Always a good practice to note your rounding, so that's not exactly that. But personally, I'm liking this answer here, square root of 145, because that is the exact value. So hopefully that explains it to you. Hopefully you guys are feeling good. I hope you enjoyed this video, and I'll see you next time. Good luck.